with the terminology, you're just filling in the blanks on your handout. A definition that we are going to see repeatedly, and it looks kind of ugly, is for a polynomial. If you have a polynomial function of degree n, where n is a non-negative integer, it is defined by an expression of this form. There is that first box there up at the top has this definition. You just need to write the highlighted part on the line. What that says is a polynomial has terms being added or subtracted. All of these a's represent coefficients, and then you have the powers of x. So please just write that part in on the line there. In a polynomial, all exponents are whole numbers. That means if it's an exponent, or if it's a polynomial, you will not have a negative exponent. You will not have a fraction exponent. You will not have a decimal exponent. You won't have the variable in the denominator because that's like a negative exponent. So if it's a polynomial, all of your exponents on your x's are going to be like 0, 1, 2, 3, 4, and so on. In this, there are some other words that we're going to be referring to. If I talk about the degree, that is the highest power. So in this case, it would be that n. It doesn't have to be the first term. Frequently it is. A lot of times we write them in decreasing order, but it doesn't have to be. So just look at all your terms and the highest power is your degree. The leading coefficient is the coefficient on the term with highest degree. So in this case, if that n is my highest exponent, that a sub n would be my leading coefficient because it's the coefficient on that particular term.
What do the numbers on the bottom mean where it's like a and it's like really low and then n?
That's a subscript. It's just saying it's the a of the term with the n for an exponent. The a with the term n minus 1. It's just a way of making sure you realize all those a's don't have to be the same number. All right, the constant is the term without a variable. So if you look in this, what we wrote down, that would be my a sub 0. It didn't have a variable with it. Alright, so what we're going to do now is just look at an example of some polynomials and make sure we can pick out the degree, leading coefficient, and constant in each of those polynomials. These are just terms that you will hear me say frequently, so I need to make sure you all know what I'm talking about. So on the first one here, what is the degree? 1. You have to look at the variable. It's just the highest exponent, so it's just a 1. Leading coefficient is just the coefficient of that term, which would be 5. My constant, the term without a variable, negative 1. Okay, second one. This is a polynomial because my radical is only over the 2. If I made the radical over this whole expression, would it be a polynomial? No, you can't have a variable under a radical in a polynomial. Okay, degree. What's the highest exponent? 4. Leading coefficient. What is the coefficient of that term? Constant. 0. There isn't one, so we just put 0. under the radical, as long as it could be simplified so you would no longer have it, then yes, it would be. Alright, last one. What is my degree? 3. It wasn't the first term, but you have to find the highest exponent, so 3. Leading coefficient of that term is 1/2 constant 5. Alright, so do we understand what degree, leading coefficient, and constant mean? One thing that I just want to point out, if you just have f of x equals 0, that's what's called the zero polynomial. And we say it has no degree. The reason is the degree is your highest exponent. 0 is the same as 0x, or 0x squared, or 0x to the 10th, or 0x to the 1000th. So do you get what I'm saying? If it's 0, you could have any power of x with it, so you can't really give a degree there. So if it's just 0, it has no degree. Now, if it's just f of x equals any other number, then that has degree 0. So if I just said f of x equals 3, that is the same as 3 times x to the 0 power, because anything to the 0 power is 1. But you couldn't put any other power of x with that.
So there will always be a degree unless it equals 0?
Exactly. If it's just a constant, the degree is 0. But if it's just equal to 0 itself, then it has no degree. Okay, today our focus is going to be on quadratic functions. So what is a quadratic?
A function?
It's a function.
Good answer.
Your eye looks worse. Yeah. So what makes it a quadratic? You talked a lot about these in Algebra 2. It's a parabola. So what shows up in the equation that makes you know? A square. So a quadratic function is a function of the form f of x equals ax squared plus bx plus c. Fill that in your box there. And that's what we're going to spend the rest of the day talking about. Okay, so like we just mentioned, the graph is a parabola. So parabolas have two options. You can have a normal parabola that opens up, or one that opens down. So parabolas will open up or open down. That will determine whether they have a maximum or minimum point. So you're just filling in the blanks on your notes handout right now.
This was really easy in Algebra 2, though it's really hard now.
Oh. So if it opens up, why do you think everything's hard this year?
I swear I'm losing brain cells.
Okay, so if this one opens up, is this point a maximum or a minimum? Minimum. If it opens down, you get a maximum. Okay, what is that name of that highest or lowest point, the maximum or minimum point? What do we call that? The vertex. So that point is your vertex. Okay, do you remember what we called, in Algebra 2, we always found the vertex and we... Axis of symmetry. It was the vertical line that went through the vertex. Alright. So we're going to talk about a couple options for graphing parabolas. And you really did both of these in Algebra 2. So first we're going to talk about the two different forms we might see a quadratic equation in. The first one, standard form, is what I already showed you, that f of x equals ax squared plus bx plus c. That's called standard form. The vertex form is a little different. It's a times quantity x minus h squared plus k, and that hk represents your vertex. Make sure you have this written down. When you have the second form, it's really easy to graph it using transformations, like we did in the last chapter, moving left, right, up, down. The first form is not so nice for transformation, so we'll talk about what to do in each scenario. So we are going to graph some parabolas. First option, let's just say I gave it to you like this. You don't know transformations for graphing that, so let's just say I went back to the old-fashioned way and I told you to plot points. Could you plot points to graph it? We'll make a T-chart. Why not? Let's try it. All right, give me a value.
2.
2,
5,
3,
12,
0. Let's try some of these and see what we get.
9,
If we put in a 2, we get 4 plus 8 minus 4. So that's 8. If I put in a 3, I get 9 plus 12 minus 4. So that's 17. So do I want to plot bigger numbers here?
No.
No, let's go the other way. So I heard a 0. If you put in 0, 0 plus 0 minus 4 is negative 4.
Negative 2.
Negative 2. So negative 2 squared would be 4 plus negative 8 minus 4. So I get negative 8. Do I have a parabola yet?
No.
Okay, so which way do I need to go? Do I need numbers bigger or smaller? Let's try negative 3. Negative 3 squared would be 9 minus 12 minus 4. 7. So negative 3, negative 7. Do I have it now? Maybe. If we can tell, I'm just going to do a quick check. If I plug in negative 1, I get 1 minus 4 minus 4, so that gives me negative 7. So that makes me feel pretty good that I have found my vertex. So if you're just plotting points, you have to plot them until you find your vertex. Until you find that point where you hit and bounce back the other direction. The issue with that is sometimes it's kind of time consuming. We had to plug in 6 points until we found it, but what if my vertex had been at negative 2/3? Would negative 2/3 be something that you would readily think of to plug in? Probably not. So is this going to be a good option for us moving forward? No. We need a better way. Now if it's written in vertex form, we've already been graphing these. So, hold on, I don't want to do that one yet. So if I gave you this one, we could use our transformations. We know what x squared looks like, so I could graph my parent function. 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1, 1. Negative 2, 4. So these are just like on that test we just took. You make your parent function dashed. Okay, what would the negative do?
Just flip it over completely over the x. Completely. Not half.
What's the 2 do? So you could really think of this like taking each of your y values times -2. So if you're at 0, 0 times -2 is still 0. Here we have a y value of 1. 1 times -2 is -2. This is a y value of 4. 4 times -2 is -8. And do the other side. So that's like the old stuff, and then we can see what our graph looks like with some exact points. Oh, I didn't read my directions. I also asked for domain and range on your handout when you do that. What's the domain of this one? What's my range? Go small to large, so we'll go negative infinity to 0. And we hit 0, so it gets a bracket. Let's look back at A. What was the domain on A? What's the range on this one?
-8 to bracket -8.
Good. So that vertex, the reason we have to have the vertex is for finding that range value. Okay, why don't you guys graph C? Parent function, transformations, give the domain and range. Alright, so if we graph our parent function, our parabola, 0, 0, 1, 1, 2, 4. If you want, you could do 3, 9, -3, 9, -2, 4, and -1, 1. So that's your dashed one. What's my transformation on this one?
Right, 3, down 1.
So, move each point right and down. Domain?
All the numbers are negative.
Range?
-1. The bracket -1.
Good. What if I asked you where this graph was increasing?
3.
Oh, yeah.
Infinity.
Yeah. What if I said decreasing?
Negative infinity.
Good. That's kind of an old question, but I could still ask it. It still applies to these things. Make sure when you're listing increasing and decreasing intervals, you use the x value, not the y. Alright. So let's talk about if it's not in the vertex form. This way we can do transformations, but they're not always written that way. We have what's called the vertex formula. This is what you really use a lot in Algebra 2 when you graph these things. So to find your vertex, remember to find the x value, you do the opposite of b over 2a. And then you plug that value in, whatever answer you get, you plug that back in to find y. So anytime I ask for the vertex, opposite of b over 2a would give you the x value of the vertex, plug it in, you get your y. You definitely want to write this down. So to find your vertex, use the formula x equals opposite of b over 2a. The axis of symmetry is just the vertical line that goes through the vertex, so it is that same thing. But I am going to be very picky. The axis of symmetry, it is a line, so you have to give me the equation of a line. So you have to put x equals. If you just say the axis of symmetry is 2, I'm going to take off a point because it's not a single number, it is a full line. How would you find the y-intercept? How do you find a y-intercept? Anytime. Okay, and what more specifically, when you find the y-intercept, what's x equal to? 0. A y-intercept is where you cross the y-axis. So to find it, you plug in a 0 for x. So what you did in Algebra 2 to graph these quadratics is you found the vertex and plotted it. You drew the axis of symmetry. You found the y-intercept. And we know that a quadratic looks the same on both sides of the axis of symmetry, so you take that y-intercept and reflect it across the axis to get your third point to draw the full graph. So we're going to try it. We're going to find vertex, axis of symmetry, y-intercept, domain of range, and graph. Alright, so we can do this. Vertex. What do I need to do to find my vertex? Opposite of b over 2a. So I get negative 2 over 2, which is negative 1. That's the x value. So to find y, you plug that in. And what do you get? So your vertex is an ordered pair. We have x and y now. So the vertex is negative 1, negative 6. Axis is x equals the x value of the vertex. So just x equals negative 1. Y-intercept. You just have to plug in a 0 for your x, and you get negative. Okay, let's graph it. So negative 1, negative 6 is my vertex. Y-intercept is negative 5. For the axis of symmetry, we're going to draw a dashed line going through our vertex. Okay, so I've got 2 points. You need a minimum of 3. So what you can say is, all right, well, my y-intercept is 1 to the right of my axis, so I'm also going to have a point 1 to the left, because it's symmetric. There's 3 points. That's enough to sketch your graph. What's your domain? What is our range? If I asked you, where's this graph decreasing? Negative infinity to negative 1, increasing from negative 1 to infinity. Good. Is the vertex a maximum or a minimum on this? Minimum.
Oh, yeah.
Since it opens up, that vertex is the low point. Alright. Let's try another one.
I did not think you were gonna say that. I got scared. I was like, ugh.
Okay. Is this parabola going to open up or down? Up. How do you know that?
It's not negative.
It's a positive coefficient. So we're going to have a maximum or a minimum? Okay, good. So, find the vertex. Opposite of b over 2a. So opposite of negative 6 over 2 times 3. And I get 1. So now plug that back in. And we get 4. So our vertex is an ordered pair, and it would be 1, 4. Okay, axis of symmetry. How do I write it? X equals 1. Y-intercept.
Plug in a 0 for x.
0, and we get 7. Okay, so let's plot this stuff. Vertex at 1, 4. Axis is x equals 1, so I'm just going to draw my dashed line going through that. Y-intercept is 7. So my 7, that's 1 point to the left of my line, so I'm gonna go 1 to the right. Domain? Right, every time. Range? Bracket 4, comma. Any questions there? You guys try C. Alright, let's look at this. So opposite of B over 2A, give me a negative 8 over 2 times negative 2, and we get 2. Plug that in, so h of 2, and you get 5. So the vertex is 2, 5. That means the axis is x equals 2. Y-intercept, if you plug in 0 for all of your x's, you get negative 3. So I'm going to plot 2, 5, x equals 2 will be a dashed line. Y-intercept at negative 3. So that's 2 units away from my axis, so I'm going to go to the other direction and plot a third point. So is this a maximum or a minimum? Maximum, because it opens down. Alright, so domain, range,
Negative 5.
good. Alright, there is an assignment posted on MathXL that I want you guys to work on now. You are able to do the whole thing. It is not technically going to be due until this section is over. We'll finish it up on Monday, so the MathXL will be due on Tuesday. However, I'm going to give you another